This is Cal, topic 4.1. We want to find the extremas of the function g of x. Well, first I want to graph the function g of x. So first, let's put this in here and take a look at the graph itself. So 3x raised to the fourth power minus 8x raised to the third power plus 6x squared plus 1, okay, and the graph. Now you see it's a little hard to see. I'm going to zoom in on this right here. So I'm going to zoom and then in, which is number 2. Press enter. We kind of get another little look at this right here. Alright, so it looks like we only have one max or min. I don't know. It depends on what this is right here. If this is a max or min inside this little part, but we'll check it out algebraically. Okay, let's take a derivative of g. We'll get 12x to the third minus 24x squared plus 12x. We'll set this derivative equal to 0 and solve. I have a greatest common factor of 12x times x squared minus 2x plus 1. All this equals 0. This trinomial factors into two binomials, x times x for x squared, 1 times 1 for 1. And the signs have to be the same, so it'll be a negative and a negative in order to get us negative 2x. And now I'm going to compress these two into one term, x minus 1 squared. And then now I'll solve for x. 12x set equal to 0 and x minus 1 set equal to 0. 12x equals 0 implies that x is 0, and x minus 1 equals 0 implies x is 1. Now, these are candidates for local max and mins. When you take a derivative of a function and set it equal to 0, these are candidates. Now, the fact that the power here is 2 makes the multiplicity of this particular 0, the multiplicity of 2. Okay. And multiplicities of 2, how should I say, fail the candidacy for being, how should I say, local or local max or mins. So that means the only local max or min is actually x equals 0. And take a look. Here, let's say x equals 0. I hit my trace button and I put 0. The star shows up right here at the bottom. So that really is a local min at x equals 0. Okay. But when we put in x equals 1, put in 1 here, enter. You notice it happens right here at that little curve. That little curve is kind of going flat. Should I say? I'll move over here. That little curve is going flat. So there's no real dip or valley or hill there. So the multiplicity 2 is right. There is no local or min or max here. Now, the graph itself looks something like this. To the left, it's going up to positive infinity, and to the right, it's going up to positive infinity. So, there is no absolute max. Again, we do have a local min at x equals 0, and out of all the spots, that's the lowest that we can go here, x is 0, so we also have an absolute min at x equals 0 as well. So, no absolute max, there is a local min, and there is a local min, absolute min.